So in this YouTube, we are going to examine the use of a Chi-Square test that's examining whether there is an association between two categorical variables. And so the assumption is that we're using categorical variables. They can be nominal or they can be ordinal. So Chi-Square allows you a lot of options to see how variables are related. There's another option of independent observations, and that is typical for nearly all of the analyses that we use. And that simply means that no participant, in this case, is in more than one category. So let's say you have a category for race. You can't have the same person in more than one race. Otherwise, the results will be harder to interpret. And you can see that a check all that apply item, which if you allow that for race, it wouldn't work. You'd have to, you couldn't use that in a Chi-Square test. But typically, the select one type of variable would work. And then you create something called a crosstab table, and that will make sense after we do the analysis. And you simply have one variable in the column and you have another variable in the row. And another assumption is the expected frequency of observations in each square of that table is at least 1, and that no more than 20% of these frequencies are less than 5. And you'll get a warning if you don't meet this assumption. You'll get a warning, and you'll know that you need to use a different type of analysis. You can use a Fisher's exact test if you don't meet this assumption. And then I think it is helpful, and this is just my opinion. This is not something I've read in textbooks, but I think it's helpful that if you consider what you might consider as a causal variable, even though Chi-Square isn't assessing cause and effect, that what you consider might be the cause of something in the column and what you might think of as the result is in the row. And then you request percentages for columns. Okay, and then this is what you do if you don't meet this assumption. You use a Fisher exact test, and that'll be clear when we do our analysis. So let's go ahead and do a Chi-Square test. Once again, for this body temperature, heart rate, sex data set, but we're going to use the categorical variables. So we don't have a Chi-Square option. And we go to descriptive statistics. And remember in that earlier slide we talked about a cross tabular table. We're going to go to crosstabs, and remember that I said something about using what we might think of as a more independent variable, causal variable, and I'm going to call sex that causal variable. With this idea that under this assumption that women are likely to have a higher body temperature than men. And we're using these categorical variables. Remember, we saw that in our correlations. So let's look at what these options are. We're just going to take the default. When you don't understand an option, take the default. I'll tell you unless you need to do something other than the default. Here, we want to get that Chi-Square statistics. So that's where we choose Chi-Square, is under statistics. And then remember, we wanted to have these percentages in the column. And that's important because that helps us interpret the results. The rest of these we take the default, and we do want to display these custard bar charts. So now we have our results, and when you do your results, you get 3 tables. This is the crosstab table, and you see we have these percentages in columns, and you can tell that the percentages are in columns because the total adds up to 100%. If we would have put percentages in rows, these would be 100%, but we put percentages in columns. The Chi-Square test result is here. See, there it says Pearson Chi-Square. This is the value. This is the degrees of freedom, and which we're not going to talk about here. And then this is the significance. Like, instead of calling it a p-value or an alpha value, which would be very easy to understand, they call it the asymptotic significance, and we're not going to go into the details of what that means. But it is significant at less than 0.05. And we're going to ignore these others because we want to know whether it was a significant result. And then here we get this very cool bar chart where we get to see males and females in this below normal range, in this normal range of body temperature, and in this above normal range. And so we can already see that women from this result are more likely to be there's more women than men in this normal and above normal, and more men in this below normal. And overall, we know that there's a significant distribution across these bars. So let's take a look at how we would interpret these results. We would say that sex was associated with categories of body temperature, and we write down the results like this. And then we can conclude that a larger proportion of males had a body temperature below normal compared to females, and a larger proportion of females had a body temperature that was normal or above normal compared to males. Now, it is important to recognize that even though we could make this generalization of the difference between males and females, we can't say that this relationship in this below normal, that there was a significant difference between males and females here or there, because we didn't test for that. We only tested the overall. Do we see an association between sex and categorical body temperature? Yes, that's significant. Looking at these, breaking it down, we can't say that these are significant differences. In fact, we see here the difference is actually quite small when we get to the above normal range. But you can see that this is kind of a global description across all of these categories.